So that is method for JXSIA. Kita mungkin kena buat panjang sikit supaya dia senang untuk di ataupun dia jadi this is theta, this is your IARA, nanti is your JXSIA. So the remaining is your EA. Means that you punya EA adalah hasil tambah V phase tambah dengan IARA tambah dengan JXSIA membentuk EA. Alright. EA adalah hasil tambah IARA, JXSIA dengan V phase. So this is how you draw your phasor diagram. Phasor diagram untuk generator lebih mudah berbanding untuk motor sebab dia tak kurang confuse. V phase tambah IARA tambah JXSIA membentuk EA. So the value here you need to calculate based on whatever you have calculate just now inside, ataupun daripada A, B dan C punya komponen yang kita kira tu. You dah kira untuk EA, you dah kira untuk I phase ataupun IA during short circuit and open circuit condition analysis. Ada soalan? Untuk soalan yang D tu, you just draw and key in dia punya values. It contains 8 mark. Sebab dia kira semua kat atas kan? Dah kira semua. But the values you have take. So you just key in, sketch the diagram and key in the values. And dalam sketch tak semestinya dia punya angle ni exactly seperti mana kalau ikut panggil apa tu? Dia punya buku protector kan? You just sketch. Just sketch. Kalau dia ni show. Betul dapat kan? Tapi kalau angle of your current, just sketch and not to be in scale lah. Okay, generator. So generator dalam tutorial saya ingat tak ada soalan ni generator ni. Dalam buku ni tengok tak? Soft copy of this textbook you have your own, dia punya link kan. Betul Liana share tak itu soft copy buku ni, electrical machinery ni, buku ni ada dapat tak? Dia hard copy tak ada lah, tapi dia still have soft copy lah, previous version punya 5th edition, yang sekarang 6th edition tapi dah tak print out. But you can have it for your reference to read throughout the theoretical terms ke apa semua tu. Nanti saya share kalau tak ada. Okay, kita tengok contoh dalam buku. Sebab kebanyakan textbook, previous textbook ataupun reference book come from this copy lah. And they just amend the parameters or their scenario. So if you understand the concept, any scenario you can cater. Contoh Okay, the example we follow this question. So you take note or draw this of the diagram. Sketch this of the diagram first. Nampak tak? Pernah? Okay, sketch this House diagram as a reference for your question. So we have here frequency, no load, frequency, full load of the system, and your system frequency, and also the sharing power of P1 and P2. So we have 61.5, we have 60 Hertz, we have slope 1 megawatt per Hertz. So here is P2, here is P1. P2, 1.0 megawatt. P1, 1.5 megawatt. Slope 1 megawatt per Hertz. Frequency system will become 60 Hertz. 1.5. Okay. Okay, to make it to avoid some confusion, 1 megawatt slope ni kita kena adjust it. The right hand side we put it 1.2 instead of 1.0. Sebab nanti nak bezakan megawatt per Hertz. Right hand side make it 1.2. Okay. Okay, soalan dia. Based on generator punya parallel house diagram, frequency given, no load frequency. So the statement here then just brief ataupun dia explain on the house diagram. The two generators supply a real load of total 2.5 megawatt right now. 2.5, and 2.5 is that 1.5 plus 1.0, 2.5 megawatt. 0.8 power factor lagging. So what are the frequency of the system operating? And how much power supply by each of the two generators? So we assume that we don't have ataupun we don't know yet how much the system frequency is. And so this is the frequency system that we are looking for. No load frequency given for both generator. The slope is given. So look up for system frequency. And system frequency. How much is the system frequency? So for generator in parallel mode, generator in parallel mode. So means that each of generator will supply their own portion based on ataupun finally dekat dia punya sistem frekuensi yang dia dah settle down. So formula untuk dia punya generator ni tak banyak pun, based on how much the slope of your ataupun speed droop of your generator, then you can get how much actually your generator is sharing. So kalau tengok dia punya contoh saya ni, so this is the portion of sharing by P1 and P2. So speed droop of your system is equal to F no load kalau ikut punya formula kan, speed drop is equal to you punya frequency P no load minus P full load divided by frequency no load minus frequency full load. And so this is your speed drop there. Speed drop kan. So kalau tengok balik kepada portion of your sharing tu, so P load adalah P1 tambah P2. P load ni adalah 2.5 megawatt. So P total adalah P1 plus P2. But P1 adalah P speed drop 1 darab frekuensi no load 1 minus frekuensi system. So you can insert you punya value of speed drop, you can insert you punya values of frequency at no load, then you can find your system frequency. So started over here dengan slope, cuma kita dah ubah dia punya slope untuk yang pertama ni jadi 1.2 megawatt per hertz. Instead of 1 megawatt per hertz, you tukar 1.2. So it has no load frequency of 61.5. Yeah, 61.5 plus 6. Okay, yang ni untuk G1, ni untuk G2. G1, G2. Reference dia G1 belah kiri, G2 belah kanan. Okay, we have slope untuk G1 still 1 megawatt per hertz, G2 1.2 megawatt per hertz. So P load adalah P1 plus P2, and speed drop untuk speed drop dengan slope sama 1.2 megawatt, yang ni 1 megawatt. So you tukar yang tu jadi 1 sebelah ada 1.2. So you akan dapat system frequency of, kalau sini 60 Hz, yang ni kena kira balik how much punya system frequency. So P1, P2 speed drop nombor 2, frequency no load nombor 2 tolak frequency system. So P total akan jadi speed drop 1, frequency no load 1 tolak frequency system plus speed drop 2, frequency no load 2 minus frequency system. You put in the values 2.5 megawatt, speed drop 1, 1.2 megawatt per hertz, frekuensi no load yang pertama 60 hertz, frekuensi system Peak loop nombor 2 1 megawatt per hertz. Frekuensi yang kedua 61.5. Ya. Oh silap. Betul. Yang satu adalah 61.5. Balik. Sebab kita refer sebab ni 2 kat sini, 1 sana jadi pening kan. So 161.5 ini adalah 60. So frequency system is your unknown parameter that you need to find. So you akan dapat frequency system berapa ni? Okay. 1 megawatt 1.2 megawatt. So di sini 1.0 megawatt, yang sana 1.2 megawatt. So sistem frekuensi dapat berapa dapat di frekuensi sistem? Sistem fungsi apa? Not supposed to be 60 lah. So dia punya step you kena elaborate lah untuk buat calculation ni. 1 megawatt per hertz kali 6 buat satu apa? So 61.5 megawatt, because hertz already been cancelled, minus frequency system hertz which is F system 1 megawatt plus 1.2 kali 6 apa ni? So dia buat apa ni? Ini 1 megawatt per hertz dalam F system. Satu megawatt per hertz F system plus 6 satu benda apa? Apa ni? Satu benda 72. minus 1.2 megawatt per Hertz time F system. So the all megawatt bring out here 2.5 tolak 6.15 tolak 72 dia dapat apa? Ataupun sistem frekuensi bawa ke sini dia jadi positif-positif. So you bring in the system frequency here which is 1.2 jadi 2.2 megawatt per Hertz F system sama dengan 61.5 megawatt tolak tambah 72 megawatt tolak 2.5 megawatt. So F system akan jadi berapa? Hasil tambah tolak ni bahagi dengan 2.2 megawatt. 2.2 megawatt. So akan dapat sahaja. Berapa frekuensi? 61.5 tambah 72 tolak 2.5 dapat berapa? 131 ni 0.5 131 megawatt bahagi dengan 2.2 megawatt per Hertz. So dapat apa? 59.55 Hertz. Sebab apa tinggal Hertz? Megawatt dengan megawatt cancel, Hertz naik ke atas tinggal 59.55 Hertz. So that is your system frequency. 61.5 initial no load. 60 is initial no load for number 1. So they can reduce further down to the system frequency of 59.55 Hertz. So how much the sharing fraction of these two generators? So 59.55 system frequency. Kalau you want to be precise, so put the unit as well dalam ni. Hertz minus 59.55 Hertz. So Hertz dengan Hertz cancel tinggal megawatt. So berapa dapat? How much the value? P1 berapa sharing fraction ni? Sharing portion out of that house diagram. 6.5 tolak 5.95 berapa? 1 point 2.95 ni kali 1 megawatt kan? Ni 60 tolak 59.55 60 tolak 59.55 kali ke 1.2 0.54. So this is the portion. So betul tak dia punya portion which is P total equal to P1 plus P2 which is 1.95 tambah 0.54. Dapat apa ni? Total tadi berapa? 2.5 dia. So this is the portion of the fraction sharing. P1 1.95 megawatt, P2 0.54 megawatt. So yang ni adalah 0.54 megawatt, yang ni 1.95 megawatt. So in term of drawing, kalau you draw, yang ni should be 3 times the width of your right hand side. So based on only one formula here. Then kalau di tambah load tu kepada certain value, see, when we increase the load daripada 1 megawatt kepada 3.5 megawatt, apa soalan dia? Suppose additional 1 megawatt load attached to this power system, dia kata 1 megawatt tambahan lah. So berapa portion of sharing becomes? Satu megawatt. So instead of 1 megawatt, dia letak 2 megawatt sekarang. Sebab kalau dia letak 1, dia tak buat dia punya ni lah, tambah 2 megawatt. Increment of another 2 megawatt plus 2 megawatt. So berapa portion ni? Kalau tambah means that dia punya portion ni akan bertambah. Dia punya width of your power ni akan bertambah. Bila bertambah, dia terhad dengan bumbung ni, so dia terpaksa turun lagi bawah. Faham tak? It limits by the roof. So when you want to widen your power, you have to reduce your system frequency because of limit by this roof. So sistem frekuensi akan jatuh menjadi F sistem yang seterusnya, F sistem prime. So how much is your system frequency now? So instead of 2 megawatt tadi, 2 megawatt tambah 2 megawatt dia jadi 4 megawatt lah. Tadi 2 Tadi 2. Sekarang 2.5 jadi. 2.5 tambah 2 megawatt, so dia akan jadi 4.5. 2.5 dia jadi 4.5 right now. So 4.5 megawatt, how much is your fraction? How much is your frequency becomes, then how much is your fraction? So same, P total adalah P1 plus P2. P1 is the speed root of your pattern, sama juga, darab how much initial frequency tolak system frequency. So total power is equal to your addition of P1 and P2. So now become 4.5 megawatt. Tulis balik 4.5 megawatt. So just and a repetition of your process. 4.5 megawatt. So find out what is your final value of your frequency. Dapat berapa? So berapa frekuensi? Dapat berapa? Logically should be lower. No load tinggi, you put load dia akan reduce, you put more load dia akan reduce further. Alright. Sistem frekuensi apa? 58. Just now 59.55. Sekarang jadi 61.5 megawatt. 58 apa? 58 apa? 64. Ada dapat lain kan? 58.64. 58.64 Hz. Ada dapat lain? Ini ada value. Oh, you agree with that? Okay. 58.64 Hz. So, how much is the sharing fraction? 58.64 Hz. You dapat berapa portion untuk P1? Oh ni 61.5 tolak 58.64 oh. Nah, 2.5 tolak 58.64 apa? Kalkulator 61.5 tolak 58.64 apa? How much? 61.5 minus 58.64. Apa ni? Ha? Louder. Ha? 2.86. So 2.86 megawatt. Same goes to P2. You just key in your calculated value of system frequency. 60 minus 58.64. How much? Okay, times 1.2.
1.63.
Apa?
1.63.
63. So 1.63 megawatt. So counter check. Is it correct or not? Prove it. Does it comply with your initial value? 2.86 plus 1.63.
4.49.
4.49 megawatt. Okay. Here, if you have any longer value, or you should pin, because we talk in megawatt, megawatt. So you have maybe 2 or 3 or 4 points, right? One dia akan jadi 4.5 megawatt. Yeah. Okay, this is what happens is that when you increase your power, the width of your space here will increase. So when you need to increase in terms of width, so it was held by your roof. So your system frequency has to be reduced to occupy your space. And if you reduce the demand, the frequency will increase because it will hold by the roof as well. It bounce there. In line work can bounce here. Okay, let's say if we have one of the roof being increased, the limit. Here we have Governor set point of G2 increase 0.5 hertz. G2 governor set point increase by 0.5 hertz. Your roof here increase, so the whole roof increase, and 0.5 is that plus 0.5. So what happened here will be increase into 60.5 hertz. So your frequency number become 60.5 hertz. So continue with B means that the same 4.5 megawatt. What are the new system frequency from that? And so new system frequency instead of 8.64, if we increase further, so what will be a new frequency? So cara how to calculate that is same. You just change your frequency of your no load here for generator number 2, frequency no load generator number 2, and you proceed further, the same. Let's say if you want to set, if we need to set your system frequency at certain value. So we need to set at, instead of we have 60 hertz, 65, we want 60 hertz, let's say. We increase 0.5%, we want to set at 60 hertz. So you just insert your 60 hertz here. Voilà. If you change your frequency for G2, so you just amend here. So saja. Is that you just follow the initial formula here and just amend the values, whatever that is given inside the formula, and calculate for the result. So you can see here the step. Just follow the same step per what we have calculated just now. Okay. So for generator, the gist of it is you draw your schematic, draw your concept, then just put a label, and based on that house diagram concept, just calculate your values. Okay. Okay, then we move to motor, which by right I should discuss in this evening group, but I don't think we have time for that this evening. So we discuss now. We take 5-minute break. After that we continue with motor, sekarang motor. Any question? Ada soalan? Ya. G2 sahaja. For C, we have here slope for G1 maintain. Only G2 increase 0.5 degree. 0.5 degree. So initially this is your half diagram. And 61.5, 60.0 hertz of no load frequency. Now, at the same sharing, last power sharing, we increase this house, this roof. How much increment? 0.5 hertz. So instead of 60.0 becomes 60.5 hertz. That's all. The height of this roof will increase. So when it increase, what happens? The sharing fraction akan berubah. Instead of it limit here just now the limit become wider. So this is G1, G2, so P2, P1, P2. So this is your P2 prime. Means that when increase, sharing fraction will increase for on G2. Okay. Yeah. We just G2 means that sharing fraction akan we increase for G2. 2.2 what? The amount? Yeah, maybe. P2. It increase lah. So the amount increase lah. How much the value? I'm not sure because we have changed the value just now. The amount increase. The amount increase, the portion is that the portion contribution from G2 will increase. Ada lagi soalan-soalan? Any question? Any question? Okay, we take 5-minute break.